In this problem, we see some gaps in this system. It's already in standard form, but there's really a 0x in front of the second equation and a 0z in the third equation. Somehow we need to choose a variable to eliminate, and since I have a gap in this second equation and already have 3 x's in the first and third equation, it seems to me that those are the ideal equations to work with. And I'm going to multiply that bottom equation by -1 so that we will have opposites on the 3 x's. So the first equation sliding over gives us 3x plus 2y plus 5z is equal to 6. No changes there. And the second equation multiplying through by -1 gives us -3x minus 17y equals -26. And as we had planned, we eliminated those x's, and adding down, I'll do this in red, we have -15y plus 5z is equal to -20. Okay, we've got an equation, which I'll put there in red. I'll put a little asterisk next to it. We've yet to use this middle equation, so I'm going to slide that down there. I'd like to, well, let's just slide this down. We're going to have 3y minus z is equal to 4, and that'll be a second equation that only involves the variables y and z. So now it's time to do something here with this. I think it would be easiest, let's look at these z's. I'm going to multiply this bottom equation by 5. The first equation will stay -15y plus 5z equals -20. And when we multiply this bottom equation through by 5, we get 15y minus 5z equals 20. And when we add down, everything gets eliminated and we get 0 equals 0. Now, this is different than the problem we just did a moment ago where we had 0 equals 6, because now this is a true statement. So what we're going to have is infinitely many solutions. Now, that's how you might have done this in your intermediate algebra class and just left it there. We want to go beyond this one step, and I want to show you another way to write this. I'm going to say sometimes we write the solution set as, and we're going to start some set builder notation here. We're going to say the set of all triples x, y, and z such that, remember how that bar is pronounced such that, and now we want to describe this intersection, which ends up being the plane. And I'm going to describe it using that top equation there, which is 3x plus 2y plus 5z is equal to 6. Okay, and we will learn more about how to handle this type of solution set when we get to section 6.2. For right now, infinitely many solutions is fine. I just want to give you a little taste of something that's still to come.